It's time for us to look at transforming the sine graph. So first of all, here is the parent function y equals sine x that has not been manipulated at all. And over here, this here is the equation for if you are going to transform the sine function. It is a sine parentheses b parentheses x minus h parentheses parentheses plus k. So let's talk about what each of these things mean. So first of all, if there's a negative sign here, it means the whole graph would be reflected across the x-axis. So it would be like this. And A is the amplitude and it affects the stretch factor. So if this was 2, for example, this would go all the way up to 2 and all the way down to 2. The B here also affects the stretch factor, but not the y stretch factor, this time the x stretch factor, and it changes the length of one cycle. So here, this here is 2 pi, but let's say it was not, if there was a number here that wasn't 2 pi, that wasn't blank, it would be different. So to find the amplitude, to find the period, you do 2 pi, because that's the parent function, over b equals the period. So in this case, the period here is 2 pi, so that means b would equal to 1 in the parent function, so that's why it's just y equals sine, there's no number there. So then the h moves the graph left or right, and the k moves the graph up or down. So now, let's look at this again. So the amplitude, how do you find the amplitude? It's from the top here to the bottom, and then divided by 2. So the total, like the y length. So here's 1, then 2, so it would be 2 divided by 2. So the amplitude for here is 1, and that's when the parent function, again, there's none here. And it's good to know the parent function because from the parent function you can look at other sine graphs and see what has changed. So now let's do some examples. So right away we can see in this one that the baseline is moved up. So here, so we can see that it's moved up 1, 2, which means the k would equal to 2. So now let's look at the amplitude. So this is here, this value is 1, and this value is another 1, 2. So then 2 over 2 would equal 1. So the amplitude would equal 1. Now, to find the period, we just need to look at one value of the sine. So, da, da. So as you can see here, it's pi. It's 2 pi. So that means we don't need to change anything because to find period, remember I said, so it would be 2 pi over 2 pi, and that's equal to 1, so yeah. Then to find the h, we need to see where it starts. So here, it's moved over from the 0 this much, and once calculating that each one of these is pi over 4, we would get this one, which is 5 pi over h, but it's moved this way. So that means h needs to be negative 5 pi over 6. So let's form the equation. So looking back here, so we said a is 1, so we don't need to write anything. So y equals sine x plus 5 pi over 6, and then plus 2 because it was moved up. Now let's look at this one. So the baseline here, this time, it's moved down 1, so that we know that the k equals negative 1. Now let's look at the let's look at the amplitude. So 1, 2, 3, 4, 5, 6. 6 divided by 2, 3. But so yeah, amplitude equals negative 3. Now what do you notice? Why is it negative? Because look, it's 1, here's the one cycle that we're going to look at, the one period, instead of going up first, it goes down, so we know that it was inverted and flipped across the x-axis, so -3. Now let's look for the h. So where does it start? What's this value here? This value here is 2 pi over 6, or pi over 3. So h would equal to negative pi over 3. So the equation would be y equals -3, x plus pi over 3 minus, pi over 3 minus 1. So that is the equation. So now we're going to look at how to plot and how to graph sine functions, since I just showed you how to analyze them. So let's start with the parent graph values. So x and y values, we'll just write them in this table. So 0, then pi over 2, if you look, because if you remember the unit circle, that's the top. The next would be pi, then 3 pi over 2, and then 2 pi, because that's one cycle. Now the y values would be 0, because the height would be 0 there. I mean the base, 0, 1, 0, -1, and 0 again. So remember, when we manipulate these parent functions, we need to use PEMDAS. Do you remember PEMDAS? Parentheses, exponents, multiplication, division, addition, subtraction. So let's do the y first. So first of all, you see here in the PEMDAS, this is multiplication. So let's do a. A equals -3, which means you have to times everything by -3. So 0, -3, 0, 3, 0. And then after we add, because it's a, and you have to add this 1 to the y, because that manipulates the y. So k equals 1. So then you have to add 1. So 1, -2, 1, 4, 1. And these values here are the final points that we need for the graph for the y. So now we need to find the x's. So first of all, let's look here. 1/2. So let's find the period first. So 2 pi over 1/2 would be 2 pi times 2, which is 4 pi. So we know that the period has to be 4 pi instead of 2 pi. And then, so b, so we'll do that to all of them. So b equals 1/2. So that means we need to multiply everything by 2. So 0, pi, 2 pi, and 3 pi. And then we have to do the h. So you have to, because you have to negative pi over 4, because remember the graph, the thing I showed you is negative h, and then so negative plus a negative makes a positive, so this would be negative. So we need to subtract pi over 4 from everything. So this would be negative pi over 4, 3 pi over 4, pi over 4, 11 pi over 4, and 15 pi over 4. And if you see here, these are the final points, and if you look, once you graph it, you'll see that this here is also a period of 4 pi, because in this equation here we see that it is 4 pi, so that cannot change. So these are the final points, and this is how you would transform a sine function. So now let's look at the cosine functions. So now it's time for the cosine function. So as you can see, the graph of the equations for the cosine function is exactly the same as the sine function, but instead there's a cosine, and each point does exactly the same thing as it would in the sine. And here, let's look at the graph really quick. So here's 1, the parent function of cosine, y equals cosine x. This is 1 cycle, 2 periods long, 2 pi long, and if you look here, The amplitude is 1 because 1 plus 1 divided by 2 is 1. Not 2. I was going to draw a 2. That's wrong. It's 1. Okay, let's look at these. So instead of using the one cycle of sine, we're going to use one cycle of cosine, and it goes from the highest point down to the lowest, back to the highest. So let's draw the baseline like we did before and see. So it's moved up by 2. So that means the k is 2. So k equals 2. The amplitude is still 1, because I'll show you in a second. Here 1 and then 1. Then divide 1 plus 1 is 2. 2 divided by 2 is 1. So the amplitude is 1. And then let's see here. What's this value here? This value here is actually pi over 3 because this is broken up into 6 parts, and this would be 2 pi over 6, which can be changed to pi over 3. So this would equal to y equals cosine x plus pi over 3 because it's moved to the left, and then plus 2. Now let's look at this one. So highest point all the way down, all the way back up to the highest point. Baseline, it's moved down. So k equals -1. Now let's look at the amplitude. 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. The amplitude equals 3. Now, let's see, what's this? So this value here is actually 5 pi divided by 6. That means the equation would be y equals 3 cosine x plus 5 pi over 6, because remember it's broken into 6 parts, minus 1. Now let's look at graphing. So like we did with the sine, we need to use PEMDAS and start with the parent function. So let's write it down. X, y. So 0, pi over 2, the x won't change, but you'll see later that the y changes. Pi, 3 pi over 2, and then 2 pi. Now the y. So at 0, the cosine value at 0 would be 1. At pi over 2, 0, -1, 0, and 1. So let's do PEMDAS. So a, first 2. So a equals 2. So multiply everything by 2. So 2, 0, -2, 0, and 2. And there's no k, so we don't have to do anything. Yay! So b here is 2. So we have to divide everything by 2. So this would be 0, pi over 4, pi over 2, pi over 3, and lastly pi. And we can check this by seeing that this is 2. So 2 pi over b would have to equal to 2. So what would this be? So obviously 2 pi divided by 2 is pi. So this has to be pi because the period is pi. And then h equals pi over 2, so we need to add that. So pi over 2, 3 pi over 4, 2 pi over 2, 5 pi over 6, and 3 pi over 2. And if you see this, this is still 1 pi long. So the period is still 1 pi. This is the final points. And once you graph it, you'll see that it is indeed correct. The amplitude is moved up, the amplitude is moved by 2, and the period is 1. Yay, 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 yay. How fun.